To the introduction of this unit, we're going to be starting off with long division with polynomials. Both the dividend and the divisor should be arranged in descending order of the degree, highest to lowest degree. If any power is missing, you still need to include it with the coefficient of 0. For example, 4x to the power 3 plus 6 must be written as 4x to the power 3 plus 0x squared plus 0x plus 2. The degree of the remainder must always be less than the degree of the divisor. If the remainder of the division is 0, then both the divisor and the quotient are factors of the dividend. You can always expand to check whether your final answer is correct. The dividend equals divisor times quotient plus remainder. Next off, we have long division. X plus 2 is the divisor, and x squared minus 3x minus 10 is the dividend. So you take the first term, x squared, and you divide it by x. You'd place the answer on the top. You take the answer that you place on top and multiply it by the divisor. Once you are done that, you're going to place the answer you got from that and place it under the dividend. You're going to subtract it from the dividend and drop down the last value, which is 10 in this case. And you're going to repeat this process with negative 5x. So once you're done that, you're going to put the answer on top, which will be negative 5, and you take negative 5 and multiply it by the divisor, which is x plus 2. As you can see, negative 5x minus 10 subtracted from negative 5x minus 10 is going to give you all zeros, which means that you have no remainder. Then you take the quotient above, and which will be the answer in the end, is x minus 5. Next off, we have the remainder theorem. So you're going to do long division as you normally would, and when you come to the end where you get all zeros normally and you realize that you don't have all zeros, that means you have a remainder. So what you have to do is take the quotient and write the remainder and the divisor underneath. So 2 goes on top and the divisor goes on the bottom. Next off, in this unit, we're going to be learning about synthetic division. This is a shorter and a more efficient form of polynomial division. This can be only used when the divisor is linear, x minus k or ax minus k. In the form of ax minus k, it must be factored to a bracket k minus x divided by a. And the quotient must be divided by the a after performing the division. The quotient's degree is always 1 less than the dividend. Next off, we have synthetic division. So let's start off with the dividend, 3x cubed plus 4x squared minus 2x minus 1 all over the divisor, which is x plus 4. To do synthetic division, we're going to have to take the coefficients of the dividend, which is going to be 3, 4, negative 2, and negative 1. After done so, you would have to put it in this formation with the L line underneath, with leaving some room under the numbers. You're going to take the plus 4, and you're going to take the negative of the number, which is going to be negative 4. And you would have to do for this for every single scenario. It's going to be the number that comes after the x. So you bring down the first term, you multiply it by negative 4, and then you place your answer under the space provided. Then you add the numbers 2 together, and then you multiply it by negative 4. Then you place it down the answers, and then you add them again, and then you multiply it by negative 4 as you please. After you're done that, your last term, or your last value, which is going to be negative 121 in this case, will be your remainder. If you get 0, that means you have no remainders, and you should continue on. So your first term would be a degree less than your dividend. So the 3 would be 3x squared. The negative 8 would be an x value. 30 would just have no x value, so it would just be plus positive 30. and the negative 121 will be your remainder. To write your remainder, you will write your remainder value on top with the divisor beneath.
Sum and differences of cubes. Sum and differences of cubes is a factoring method used in a special case scenario when there are two values that are cubed or that are cubed being added or subtracted to each other. Sum of cubes. Now the sum of cubes formula states that a cubed plus b cubed is equal to a plus b times a squared minus a times b plus b squared. Now we're going to see if the right side equals the left side, so we're going to expand the right side. We're going to distribute the a value and the b value. After distributing the a and b value, we see that negative a squared times b cancels out with a times b squared, a squared times b, and a times b squared cancels out with negative a times b squared. And it equals a cubed minus b plus b. Now let's do an example. 27x cubed plus 125. Now, the 27x cubed is a cube because 3 to the power of 3 and x to the power of 3 are cubes. And 125 is a cube because 5 to the power of 3 is a cube. Now, if we plug those values into our sum of cubes formula, we'll get 3x plus 5 times 3x squared minus 3x times 5 plus 5 squared, and then that'll equal to 3x plus 5 times 9x squared minus 15x plus 125, and that's our answer. Difference of cubes. Now the difference of cubes formula states a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Now we're going to see if the right side equals left side, so we're going to expand the right side, and we're going to distribute the a and b value. We'll get this. So a squared times b is going to cancel out negative a squared times b, and a times b squared is going to cancel with negative a times b squared. Right side equals left side. Now let's do an example. 128x cubed minus 54. Now off the bat, this doesn't look like a difference of cubes question, but after you factor out 2, you can see that 64 and 27 are cubes because 4x cubed is a cube and 3 to the power of 3 is a cube. Now if we plug that into the difference of cubes formula, we get 4x minus 3 times 4x squared plus 4x times 3 plus 3 squared. And then after that we get 4x minus 3 times 16x squared plus 12x plus 9.
Happy birthday, Dad.
Hey, thanks, son. This is a big one. 35.
35. Wow. It's hard to believe I'll be there myself in
4 years.
4 years.
Look, I figured you would have asked me about this by now, but I know you're not really that good at math.
What are you getting at, Dad?
I'm not your real father.
You almost had me that time. You almost had me. Not my dad. What next? We're not black?
Solving polynomial inequalities by graphing. Step 1. Rearrange all terms to make one side equal to 0. Step 2. Factor completely using appropriate strategy. Step 3. Graph the factored function. Step 4. Eyeball and state the intervals that satisfy the question.
Let's say we're given this equation, and we have to find when f of x is greater than or equal to 0. So our inequality is going to look like this. X to the power 4 minus 3x cubed minus 13x squared plus 51x minus 36 is greater than or equal to 0. Let me fix up the 6. So I'm going to factor this, and I'm going to get x plus 4 times x minus 1 times x minus 3 squared is greater than or equal to 0. Now let's graph this. First I'm going to plot my roots, and they're at negative 4, 1, and 4. So I'm going to draw a line going through negative 4, going through 1, and bouncing off of 4 because it's squared at that root. Okay, and I'm going to draw arrows saying it goes all the way to infinity and negative infinity. And the part below the x-axis is not a part of our inequality because it's greater than or equal to 0. The part above the x-axis is a part of our inequality, and that's the answer to our inequality. I'm going to label this f of x, and f of x is greater than or equal to 0 at an x value that is from negative infinity to 4, union with 1 to infinity, because it never goes below the x-axis after 1.
Step 1. Rearrange all terms to make one side equal to 0. Step 2. Factor completely using all appropriate strategies. Step 3. Draw a number line using your factors, which will divide your domain into intervals. Step 4. Choose any x value within each intervals. Don't pick the factors, and plug the equations. Write down the y values. Step 5. Choose the interval that satisfies the inequalities by using the y value. Step 6. State the final answer in the interval notation.
Now let's do the interval method, also known as the line method. Now let's say we're given this factored inequality. So we don't have to do the first two steps because it's already factored and doesn't need to be rearranged. For this method, I'm going to state the zeros or the roots. So the roots are at x equals negative 4, x equals 1, and x equals 3. Now I'm going to draw a line with the roots on it. The line goes all the way from negative infinity to infinity. I'm going to put the roots on the line, and I'm going to put the infinity and negative infinity signs as well. Now I'm going to write the intervals of the line. The intervals are from negative infinity to negative 4, negative 4 to 1, 1 to 3, and 3 to infinity. I'm putting round brackets around negative infinity and infinity because we never touch those values. And I'm putting square brackets around the numbers because the inequality is greater than or equal to 0. Now I'm going to label these intervals A, B, C, and D. And now I'm going to plug a number in between these intervals into the inequality. Into the polynomial. So if I get a positive answer from the polynomial, it'll be greater than or equal to 0. So if I plug in negative 900, I'll get 6.58 times 10 to the power of 11. That's positive, so this is greater than or equal to 0, so it's a part of our answer. For the next one, I'm going to plug in negative 3, and I'll get negative 144. Now, because this is a negative, that means that it's less than or equal to 0, so it's not a part of our answer. Now I'm going to plug in 2, and I'm going to get 6, so this is a part of our answer. And now for the last interval, I'm going to plug in 900, and I'm going to get 6.53. No, I'm going to get 6.54 times 10 to the power of 11. And this is positive, so it's greater than or equal to 0, so it's a part of our answer. So our answer is g of x is greater than or equal to 0 at, now we're going to put our positive intervals. So x is the element of all real numbers from negative infinity to negative 4, union with 1 to infinity. And our last interval is the merge of the last two positive intervals because this polynomial has to be greater than or equal to 0.
Now let's do the chart method. For the chart method, all your roots go on the top and the corresponding factors go on the left. These should be in ascending order. So now we're going to put a minus sign for when the result of the factor is a negative number, when there is a number substituted in that is less than the root. For example, when I plug in a number less than -4 for the factor x plus 4, I get a negative number. So I put a minus sign here. If I plug in -4, I will get a 0, so I will put a 0 on the line. If I plug in a number greater than -4, I will get a positive result, so I will put a plus sign. Same with the rest of the roots. Now for the next row, if I plug in a number less than -4, I will get a negative result. Same with the next root. If I plug in 1 though, I'll get a 0, so I'll put a 0 on the line. If I plug in a number greater than 1, I will get a positive result. Same with a number greater than 3. Now for the last root, I will get a positive answer if I plug in a number less than -4 because the factor is being squared. If I plug in a number less than 1, I will get a positive answer because it's being squared. Same if I plug in a number less than 3, I will get a positive answer because it's being squared. If I plug in 3, I will get 0. If I plug in a number greater than 3, I will get a positive result. Now I'm writing the overall. The overall is the overall sign, and this follows the multiplication rule of integers. So a negative times a negative according to the integer rule will equal a positive. Times that by a positive, I will get a positive, so my overall sign is a plus. Now for the next column, positive times negative is negative. That times positive is negative, so my overall sign is a minus. Positive times positive times positive is positive, so my sign is a plus. And positive times positive times positive is just positive, so it is plus sign. The intervals that will answer the question will be the intervals that are positive, and these are positive. The interval will be from -infinity and 4 and 1 and infinity. So the answer is g of x is greater than or equal to 0 when x is an element of -infinity to 4 union with 1 and.
Now let's say we're given this application question. The GDP of Tibet has been following the function g of t for many years now, where g is the GDP and t is the time in years. Assuming the GDP of Tibet is going to continue to follow this function, how many years after 2013 will it take the GDP of Tibet to exceed $82 billion US, and g of t is equal to t cubed minus 4t squared plus 10. To solve this question, you need to make this into an inequality, so this function has to be greater than $82 billion US. So it's going to look like this. Then we're going to rearrange and then factor. So after rearranging, I get t cubed minus 4t squared minus 72. Now I'm going to factor. You can factor using long division or synthetic division or graph it. I'm going to use synthetic division, so I'm going to find the divisor. The divisor I found was 6, and for long division you need to use the factor t minus 6. Now I'm going to put my coefficients in, and I'll put 1, -4, 0 as a placeholder, and -72. Then I'm going to put my divisor on the left, and now I'm going to use synthetic division to solve. So after I'm done solving, I'll get the remainder as 0. Now I'm going to write my quotient as a quadratic. My quadratic is going to be t squared plus 2t plus 12. Now before I factor, I'm going to see if this quadratic even has roots. So I'm going to use the discriminant, which is b squared minus 4ac. Now I'm going to plug in my values, and then I'm going to solve, and I'll get -44. And that means that there are no roots. Now I'm going to use the chart method to solve this inequality. Now I'm going to put my root on top and my factor on the left. All the values before 6 are going to make this factor equal a negative. All the values after 6 are going to make it equal a positive number. The overall is going to be minus plus. Therefore, the GDP of Tibet will be greater than $82 billion after 6 years. And I know this because the intervals are from -infinity to 6 and 6 to infinity. And 6 to infinity is the right answer because it's positive in that interval.